Let's try and learn about curve sketching. Curve sketching is a very practical application of differential calculus. How does a function look? What a function looks like? How does it work? How does it move from one point to another point? That is what we will be looking in the lectures of curve sketching. So first differentiation that I want you to know is in two terms. The two terms mainly increasing and decreasing function. You should clearly know what do you mean by an increasing function and what you mean by a decreasing function. Now, the derivative of a function can actually tell you that. How do you get to know? By the derivative of a function. It tells us whether a function is increasing on certain interval or decreasing. Now, in case your derivative is greater than 0. In case your derivative is greater than 0. So what does that mean? That means that your derivative looks like something like this. It's increasing. So this means that a function will be, the derivative is greater than 0 here. This means that the function will be increasing. It's moving upside. On the other hand, when you have a derivative which is negative like this, okay, slope is like this, so the function will be like this, where your function is actually decreasing. So you understand that's the difference between an increasing will be like this, decreasing will be like this, or many other shapes actually can define that. Okay, now the intervals of increase and decrease will occur between mainly 2 points. Which point? Points where you have f dash equals to 0, that is tangency points, and where your f dash x is not defined. F dash x is not defined for certain reasons. These points are not necessarily critical numbers because we include x even if it is not in the domain of f. You will understand about it later when we talk about critical points. Now, critical points are the points which should be in the domain. But right now, for our concern, we are only looking at increasing, decreasing function. What we are trying to say is there would be certain turning points, and turning points can only happen here when your f dash x is 0 or else it is not defined. So that is where your function will be, in those intervals the function will be increasing or decreasing. So let me take you through another such example now, and just look at this diagram very carefully. I have made certain slopes for you. Here you have your slope a between a and b. These are the slopes, okay, and between b and c, just see the slopes. What is happening? Just see what is happening. Just see what is happening. Now, what is happening essentially is that between a and b, the slope is what? Negative. Can you see that? The slopes are negative between a and b. These are like this, okay, and the function is decreasing, okay. Slope is negative. Here what is happening? Your slope are positive, and you see your function is actually increasing. And again, between c and d, the slope are negative, and you see that the function is decreasing. So in short, what I mean to say is that the derivative f dash x is negative from a to b, and the function is decreasing, and the same is happening between c and d. From b to c, the slopes are positive and the function is increasing. Okay, so that is how you look at a curve where it is increasing or decreasing, and that gives you the shape of the curve.